Question 1 about the parachutists. This comes from the 2019 AS exam paper. We got 1 mark just to get you thinking first of all. And we can see that it was falling for 3 seconds using gravity at 10 meters per second squared. So the velocity is 3 times 10, which is 30. Now clearly if you did want to do this as a big Suvat equation, you could do u equals 0, v equals question mark, a equals 10, and t equals 3. We've got exactly the same. 0 plus 3 times 10, which is 30. So we can do it in either way, but it was supposed to be just a warm-up question to get you started. Because then you had to draw the graph for this thing. Had a couple of people not starting in the wrong place, but most people knew we were starting at 0 here, and we'd accelerated to 30 meters per second. It then says we're going to decelerate for 2 seconds. So we're going to decelerate here for 2 seconds, so that takes us down to 5. And then it says it's going to be constant. Sorry, it says that somewhere. Yeah, constant. There it is. It's going to stay constant at this speed for the rest of the time there. Now, a few people did a straight line going down like that, and which I know they were just doing the end of their shape, but they lost a mark for that because that suggested that the velocity would go straight down to 0, and you weren't having that. So the next bit, just to think about this, would be what would that speed there be? And it was starting at 30, it's gone down 12 for 2 seconds, so it's gone down 24. That would be there at 6. And so there's our sketch graph. Well, what we now need to do is find out the area of all of this. Again, I had lots of people using Suvat equations to do all this, but it's much quicker just to look at it as these 3 separate shapes. Shape 1, shape 2, shape 3. Well, shape 1 is just a triangle. So if we just do a half times the base times the height there, we can see that that one there is 45 meters. Shape 2, well, this is a trapezium. And the trapezium is half of the sum of the parallel lines, so that's 6 and 30, times the distance between them. Sorry, I'm going to sing because I do for the GCSEs. That's the way you find the area of the trapezium. So that gives us 36 meters there. And then area 3, well, area 3 is from here to here, so let's just call that x, times by the height there, which is 6. So I've got 6x for the area there. And the total of all of these areas, 45 and 36 and 6x, they tell us it's 550 meters. So if we take these two off, I think that makes 499. Sorry, I lied, 469. And then 469 divided by 6 tells me that x is 78.2. So this part here is 78.2 seconds. One more bit to go is that the total time is these extra 5 seconds as well. And so t is 83 to the nearest second. It asked us to round it. The worded bits at the end of this, and I've included what the examiner's report have put in here, because I say this was a real paper. But how would t compare? So we were looking at that t is larger, or t is greater. Just the 1 mark just for writing that. You couldn't say it took longer. You weren't allowed to do that. And one further suggestion, the most obvious one is if you use G as 9.8 rather than 10. But there were lots of other ones as well about the effect of wind, the effect of spin, the fact that they don't fall vertically. The one that lots of people